In this video, we're going to solve a trigonometric problem which appear in JEE Advanced 2020. So here we have a triangle and whose sides are XYZ and the angles are XYZ. Okay, and it says that that tan x by 2 tangent by 2 is equal to 2y x plus y plus z. So here the caps x and caps y caps z represent the angle and small x small y small z represent the side length. Now we have to identify which options are correct. So therefore, in this particular problem, multiple options are correct. So let's go ahead and solve this one. So here, first, before going ahead and solve this problem, we are just listing out the properties of the triangle using the trigonometry. So first here we consider a triangle ABC where the side length are given. So here we consider that ABC is a right angle triangle, and based on the vertices we define that ABC, and the side length BC opposite to the angle A will be small a, opposite to the angle B will be small b, and similarly for C. Okay, that's it. So this is a normal methodology we'll use in trigonometry. So here first we recall that what is semi-perimeter. We already learned that semi-perimeter in that 910, that is called Heron's formula. So here AC is 1 by 2 sum of all the sides. First we consider the sine rule. Sine rule says that sine A by A, sine B by B, and sine C by C is equal to 1 by 2R, where R is the radius of circumference of the circle. Go ahead for the cosine rule. Cosine rule states that cos A, the cos of the angle A, will be b square c square minus a square by bc. Cos B will be c square a square minus b square by 2ca. So see that if the angle is b, so minus b square is subtracted. See that cos c square is subtracted. So this is the easiest way to remember. And what is the area of the triangle? Area of the triangle says that area of the triangle will be half BC and the angle between them, that is angle A. So therefore BC sine A, CA sine B, and AB sine C. And there is another formula, that is tangent half angle. This is will be used here. Why? Because see that here we are going to find out the expression for tan x by 2 and tangent by 2. So that's why we use the half angle formula. So here, tan A by 2 will be delta divided by S into S minus A. S into S minus B, delta, that is B by 2, and so on. So what is delta? Delta will be the area of the triangle. So these formulas will be used, maybe in all of them or one or two, will be used to solve this particular problem. So now let's concentrate on the problem and we solve it. We consider the triangle XYZ where the side length and the angle are defined by the normal nomenclature. So the vertices are defined at angle XYZ and the opposite side will be small a, small y, small z. Therefore, we can apply the tangent half angle formula. Using that, we can find that tan x by 2 will be delta divided by s into s minus x, and tangent by 2 will be delta divided by s multiplied by s minus z. Now, let's proceed. Now, what is given? Here, see that we need to find out tan x by 2 and tangent by 2. So that's why we just consider that term. So we add that delta terms, right? So see that delta by s can be taken common, and remaining inside will be 1 by s minus x, 1 by s minus z. So we do the LCM and added them together. So therefore, we get a delta by s into s minus x, s into s minus z, and 2s minus z minus x. Now we know that the semi-perimeter will be sum of all the sides divided by 2. So therefore 2s is equal to x plus y plus z. Hence if I substitute, we'll get it that very simplified form. It will be delta y divided by s into s minus x and s minus z. Notice that it is given that tan x by 2 and tan z by 2 is be equal to 2i divided by x plus y plus z. So therefore, if I use the whatever we derived using the tangent half angle and whatever is given, so y get cancelled. And but here notice that, right, that x plus y plus z can be written as 2s, right? So therefore, we just rewrite it as, right, delta y by whatever 2y by 2s. So 2 get cancelled, y get cancelled. So therefore, we can obtain that delta is equal to s minus x multiplied by s minus j. So therefore, that delta, that means the area of the triangle, is obtained. So now notice that what is delta? Area of the triangle. So we can find the area of the triangle using the Heron's formula. So using the Heron's formula, we can easily identify that square root of s into s minus x, s minus y, s minus z is equal to s minus x, s minus z. Just square both sides. So if I square both sides, we can see that s minus 1, s minus x, s minus z will be cancelled. So therefore, s into s minus y will be s minus x and s minus z. Let's multiply by normal multiplication. A square get cancelled from the both sides. So therefore, if I take all s terms in the left hand side, we'll get s into x minus y plus z is equal to zx. Now, notice that we already know what is S. What is S? S is equal to 1 by 2 of sum of the areas. So wherever you see S, let's substitute that. So 1 by 2 x plus y plus z divided by 2 multiplied by x minus y plus z is equal to zx. Now our job is to multiply that, the left hand side. To see that the left hand side multiplication, it takes some time. So that's why we just rewrite or the bracketed the term in such a way we get that a plus b into a minus b, because it is possible here. And therefore, we can say x plus z whole square minus y square is equal to zx. If I expand the left hand side of the x plus z square z whole square term, it gives x square plus z square plus 2zx is equal to 2zx, right? That's it. So therefore, we get x square plus z square is equal to y square. We obtain a relationship between the sides of the triangle. Now, it is clearly states that, right, x square plus z square minus y square is equal to 0. So therefore, we can see that option D is false. Now, why it's false? Because see that if x square plus z square minus y square equal to 0, then zx is equal to 0. So therefore, either x is 0 or z is 0. And side length of the triangle cannot be 0. So that's option is eliminated. Now, notice that also for a triangle, x square plus z square plus y square implies that it satisfies the Pythagoras theorem. So therefore, in this case, zx is equal to y, that will be the hypotenuse. So therefore, the opposite angle, that is angle y, is 90 degrees. So therefore, using the angle sum property, sum of the remaining angle x and z is also 90 degrees. So therefore, angle y is equal to angle x and angle z. So therefore, option B is correct, but option A is false. So therefore, we obtain one correct option. Now we have to test the remaining option, that is option C, because A and D we already checked that it is false. We know that what is the area of the triangle. So if the area of the triangle, we may have BC sine A, CA sine B, and so on, right? So using that, right, we can find the area of the triangle will be 1 by 2 ZX sine Y. Now, why we consider that one angle Y? Because that angle we know. Or otherwise also, we know that if Y is 90 degrees, it's became a right angle triangle. So therefore, right, height and base, so multiply and divided by 2 will be the area. So you can use that concept as well. So whatever, if I say that it will be 90 degree, the area of the triangle will be 1 by 2 zx. So hence, right, we can find that tan x by 2 will be equal to zx divided by 2s minus 6. So what we actually did here, basically, right, we already calculated, right, tan x, right? So here, wherever we see delta, that we substitute, okay? That's it. Now here, notice that I have to get the value in the form of the side length, right? Because see that we are testing for tan x by 2 where it is x by y by z. So that's why in this last expansion, right, wherever we see a's, that will replace by the semi-perimeter formula, or say 1 by 2x plus y plus z. So first here we consider the denominator, a's into s minus x. So if I substitute wherever we see x by 1 by 2x plus y plus z and calculate. So see that whatever there in the curly bracket, from there we can take 1 by 2 common. 1 by 2 is already present, so it will be 1 by 4 x plus y plus z multiplied by y plus z minus x. Again, if we bracket appropriately and rewrite it in the form of a plus b into a minus b, so therefore we get it as y plus z whole square minus x square. And if I expand whatever there inside the bracket as y square plus z square minus x square plus 2yz, because that's the expansion. Here, notice that x square plus z square is y square. So therefore, wherever you see y, right, y square, we just replace by x square plus z square. So if we do so, right, we get it as 1 by 4 2j square yz, or 1 by 2z into z plus y. So therefore, tan x by 2, whatever we calculated, that function, the denominator is already obtained. So 2s into s minus x will be equal to z into z plus y. So we obtain. We just substitute that expansion in the tan x by 2 formula. So if I do so, right, it gives me that zx divided by z into z plus y, which is equal to x divided by y plus z. And therefore, option C is also correct. So therefore, for this particular problem, two options, option A and option C, are correct. And that's it. So here, to solve this problem, basically we are solving using the properties of the triangle. So it's a step-by-step process, little lengthy, but as it is an advanced problem, so it's an interesting and a good problem. Okay, so hope you understood the problem. Thank you.